thanks for joining us after last week's mishap. And I really appreciate you taking time to join me this morning or this evening, wherever you might be. It's still pretty dark here in California. These sessions are what we call API security workshops. We do them for a lot of companies. We do them at a lot of conferences, and really a great way to raise awareness and really cover the basis of API security. So that's what we'll be talking about here today. The way this session is structured is I'll talk about why API security is so important right up front. That's probably the first 10 minutes or so. We'll talk about why attackers are targeting APIs, how they're being successful. We'll then move into some real world breaches and kind of blend that with the OWASP API security top 10. So we'll talk about some real examples and then how that maps into the API or the OWASP API top 10. Then we'll move into the three pillars of API security and start talking about what you can do as organizations to keep your APIs safe, and wrap up with a top 10 list of best practices. So again, thanks everyone for joining, and sorry for it's just a little early here. It's 7 a.m. and it's actually a holiday here in the US. So anyways, grateful to have you all here. To get started, of course, you're all very well familiar with APIsec University, or at least I hope you are. And one of the things that we're actually doing is, well, if you're not familiar with APIsec University, please check it out. It's our site with all these wonderful free courses taught by Corey Ball and Jason Harmon, a couple by me as well, some partners, but really fantastic content, all free, all have certifications and the like. And one of the things that we're doing here today is we want to start generating some knowledge from you all, from the community, right? So we're actually doing an API security market survey. Like, what are the things that are pressing for you, right? And we're actually going to do a giveaway. So hopefully that link showed up on your screen there. But what we're doing is we're going to give away some CASA exams, and the way you can enter is to help us out by taking the market survey, right? So you can just click on that link there, and I'll leave that up for a few seconds here. I can pop it back up at the end of the session, but really want your thoughtful feedback. It's about 10, 12 questions, and then a few about, like, what kind of organization you work for and so forth. But would really like that. We're going to collect all this information. Oh, you want that in the chat? How do I do that? Christine, maybe you can add that there into the chat, please. But thank you, Jose. And thank you, Enrico. Midnight in Japan. So that's that. Let's dive right into the reason why we're here. So the first thing is, why are we talking about API security? Why is this a hot topic? And it really starts with these three elements. So the first is the API explosion. And, APIs have really just taken off, right? It's powering everything. It's 83% of our internet traffic, according to Akamai. That stat's a few years old. I've heard of north of 90% these days. So it's really an amazing technology. It's powering all our web and mobile apps and things like that. But it has also come under the attention of attackers, right? And for many years, Gartner has been predicting that APIs would become the #1 most frequent attack vector. And I'm not sure about most frequent, but certainly the most successful, right? We see lots and lots of breaches. We'll give you some real examples here. And so they stand by that statistic. The other is we're just not doing a great job of securing our APIs, right? This particular stat from Rapid API, only 4% of all the testing that we do on APIs is security-focused testing, right? We do a lot of performance and unit and integration testing and the like. And there's various reasons, right? It's not like we're all, not paying attention. There are reasons why it's hard to keep our APIs secure. So why are APIs so attractive to attackers? And if you think about where they sit, they're really this choke point, right? This gateway between all that front end UI experience capability that we offer to our customers and to our partners, even through public APIs that we share to the outside world or to trusted parties. APIs connect that with all the, excuse me, all the back-end information, all the back-end data and functionality and transactions and so forth. The APIs power all our microservices. It's how we build our applications. So this is, you can just see like APIs. If you can find a flaw there at the API, then you can really access a lot of information that maybe you shouldn't have access to. Another reason why API attacks are succeeding is they're fundamentally different, right? So if you think about, you got the front end, you got the API that connects you to all that back end information, right? And a lot of what we do is to secure at that front end layer, right? So, authenticating users, filtering what data they can see, only showing certain buttons, but not other buttons based on their roles or, status and things like that. A lot of our scanning, right? We do a lot of web app scanning and, web app pen testing and things like that. And this is really all sort of focused here at the front end. But what do your attackers do, right? Well, what they're doing is they're going right around all that front end, right? They're going around the UI. They're bypassing all those security controls that exist and target your APIs directly. And what they often find there are APIs that are over permissioned, return more data than necessary, expose functionality that isn't exposed into the UI, can expose logic flaws and things like that. So it's really a ripe target for attackers, and often not nearly as secure as the front end. So the pro tip here is your UI is not part of your security stack. It may feel like it's part of your security stack. It may be a very convenient place to implement or enforce certain controls, but it's not, right? The fact that attackers can go right around it is proof enough. And there's lots of examples that we'll talk about how attackers are specifically looking to attack you this way. Another reason why API attacks are so appealing is if you think about like the classic cyber attack, right? What you may have heard of as the kill chain. It's kind of a complicated multi-step process from recon to, weaponizing and escalating your privilege and finding the data and exfiltrating. It's very, it's cumbersome, it's time consuming, it takes a lot of technical competence versus an API attack, right? And so what your attackers are going to do is they're going to spend time doing recon, looking for vulnerabilities, testing your APIs, trying different things out. But once they stumble across a vulnerability, they're pretty much done most of the time, right? They can go straight to breach at that point, and you'll see examples of exactly that. All right, and the last thing here in the kind of opening introduction here is that your auditors are really starting to pay attention to APIs, and the regulations themselves are starting to speak very specifically about API security. And I see a message from Lexter. I'm going to add your question to our question list, and I'll make sure we get to it here a little bit later. But on the regulatory side here, you might have heard about the SEC 4-day breach notification requirement. It's a pretty significant change in how things get done here in the US. So if you got a breach, you got 4 days to report it. But what's not talked about as much is equally part of this regulation is a public statement, a public disclosure of your organization's cybersecurity practices and strategies and maturity, right? And that needs to be part of your annual report if you're a publicly traded company. And that's really shaking things up because organizations, especially CISOs, now are standing up and saying, hey, we got to have the tools, the budget, the people, the capability to really adequately address all our security risks, and APIs are very much one of them. Then you got PCI, which has a brand new version. So this is the credit card regulation, payment card industry regulation. This year, in just 2 months from now, DSS 4.0 becomes law of the land, meaning that everyone that processes credit card transactions and is subject to PCI needs to adhere to the 4.0 requirements. Well, if you looked at 3.2.1, which is the last edition, and it's about 6 or 7 years old, there's not a single mention of APIs in there. But if you look at 4.0, it's all over the place, right? You have to look for business logic flaws, manipulation of APIs, continuous testing, shifting left as much as possible, training developers on risks and how to mitigate them. That's all in there in DSS 4.0. So APIs are extremely relevant if you're subject to PCI. The other thing is we have a whole course just dedicated to API or to PCI compliance. So if that's of interest to you, please go check out our course on APIsec U. The next two are sort of related. They're both privacy-oriented regulations. So GDPR and HIPAA don't specify how you need to achieve the goals, but the goal is you have to protect users, consumers' privacy or protected health information. And you'll see in the examples, really example after example of high volumes of PII and PHI harvested through APIs, right? APIs are how you're going to violate GDPR or HIPAA, certainly in high volume. So it's extremely relevant for all your privacy initiatives and the like. Okay, so that's the intro section. So let's start talking about real world examples and why this is not just a theoretical or hypothetical type of cyber risk. This is happening every day, every week, and it's high profile and it's causing some pretty significant breaches. We'll talk about most of these, but what you're going to see here is things like unauthorized trading, account harvesting, account takeover, data exposure, tampering, ransom, you name it, right? And when I sort of step back and look at all of these API breaches, what sort of stands out? Well, first of all, the attacks are different, right? They're not what we see. They're not cross-site injections and SQL injections and this kind of thing. These are things that are succeeding, even though we've got web app firewalls in place and we're doing our source code analysis and static code analysis and all these kinds of things. These breaches are still happening, right? So it means we got to step up our game in various ways. So I appreciate you all joining here to start your journey on how to better secure your APIs. And one of the conclusions that I can't help reaching is the need to involve development in the security effort, right? And security can't be something that's bolted on at the end when APIs are live and put into production. It just can't work that way because, as you'll see, more often than not, the fix for these vulnerabilities that got exploited is back in the code, right? Whether it's implementing some logic or an authorization rule or something like that. And so really helps to make sure that the people developing our APIs are aware of these risks. Now, I'm going to talk about some real breaches, but I'm going to weave them into the OWASP API Security Top 10. And if you're not familiar with this, this is really the industry standard for API security risks. You're probably familiar with the web app API top or the web app top 10 that OWASP is famous for. Back in 2019, they made an API specific edition, and in 2023, they updated it, kind of the V2 of this list. Some things got added, some dropped, some merged, some new things. So I'll talk about each one of those, but in the context of these real world examples. So let's dive in to our first example, which is Coinbase, which is the crypto marketplace. And so here a researcher wanted to poke around the Coinbase platform and see if they could find any issues or flaws or anything like that. And like a good hacker, started by setting up an account. They put a bit of money in there and they started trading and using the UI. And what do attackers do? They watch the traffic between the front end and the back end, right? And they're looking for those APIs that are powering various features of the application. Whenever he made a trade, he saw this is what the payload of the API looked like. And there were 4 parameters, right? There was what he was selling, in this case, Ethereum. Was he on the buy or sell side, and the source account and the target account, right? So whenever he wanted to do a trade, that's all he needed to supply. You could see down here at the very bottom, he actually owned 0.0243 units. He actually owned of Ethereum. And so again, like a good hacker, instead of using the UI, he started trading directly on the API, right? He was already authenticated in his browser, so he could trade directly on that API, and it worked. So also, like a good hacker, a lot of times what they'll do is try to get error messages out of your system to, a lot of times those error messages can reveal useful information about like what kind of data it's expecting or the tech stack or these sort of things. And so he ran a trade. He actually owned Ethereum, but he changed that Ethereum to Bitcoin and tried to run a trade and was expecting to get an error message and maybe some useful information. But that's not what he got back. What he got back instead was $43,000 deposited into his account. What happened was it actually traded his Ethereum as Bitcoin, something far more valuable. And I think at this point probably thought he was going to prison and went online and talked about this quote market nuking vulnerability that he found. And does anybody know the CEO's email address? Well, Coinbase gets a lot of credit in my book. They responded immediately. Not everyone does. And they shut down the marketplace. They reproduced the issue. They fixed the issue, which actually wasn't very hard to fix. And they rewarded this guy with $250,000 bug bounty. But they also went ahead, and I think this is really cool at Coinbase. They blogged a week later about what happened. And you can find this blog, right? It's on February 18th, 2 years ago. The root cause was a missing logic validation check, right? And what does that mean, right? It means that their app was checking if he owned 0.0243 units, but it wasn't checking of what, right? And that's a simple one-line piece of code into the application, and this doesn't happen. But they assumed that users were going to use the UI, and in the UI, you could never carry this off. You could only do this through the API. And so this is a great example of a logic flaw, right? A business logic flaw. And so that's, really the types of things that you, as developers, as creators of APIs and security teams, this is what attackers are looking for. How can your API get exploited down to the logic level? Okay. Next one to talk about is Peloton. So someone found an API, again, that was powering some functionality in the application, the Peloton app. They watched the traffic between the app and the backend, found this API, and discovered they could call it directly with no authentication, and it would return any of 4 million users in the Peloton database. Even if you marked your account as private, this API still had access to it. Even President Joe Biden's records were included in this 4 million. Now, after some time and a lot of public embarrassment, frankly, a lot of public media coverage, Peloton went and fixed it, right? And what they did was they added authentication to that API endpoint. So now you couldn't just call it anonymously or without credentials, but fairly easy to go and create an account on Peloton, and with that you could go ahead and call this API, and then you still had access to all 4 million users. And that is an authorization flaw, right? So they fixed authentication, but forgot to address authorization, which is, what can I see? Dan should only be able to see Dan's records, not Christine's, right? Or anybody else's, right? And so here's my second pro tip, which is authentication is not authorization. We'll see a lot of examples where user A is able to access user B's records, and that is an authorization flaw. And more often than not, needs to be tackled within the application logic itself, right? So now both of these examples fit well under item number 1 of the OWASP top 10, which is broken object level authorization. You might have heard it as BOLA. This is number 1. It was number 1 in 2019. It didn't change. And it's number 1 for a good reason, right? We see lots and lots of examples. And by the way, as I talk about these OWASP top 10, we have a whole course that Corey did specifically covering the top 10. So if you want to go deeper into all of this, recommend you take that course. But BOLA is the most common example is user A accessing user B. That's what it's all about, right? It's an authorization flaw. Now, let's move on to API number 2. And the example here is Duolingo. This is from, 5 or 6 months ago. 2.6 million records harvested through this API, right? And how did they do it? Well, they found an API endpoint where you could supply an email address, and if it was a valid account, it would return all this data. And because I love this. I love this community so much. I went and tried it out, and I hacked myself. This is literally my data I'm sharing with you. That's my email address. You can see that I've got a 624-day streak. I'm learning Italian. I should be more fluent by now. But literally, this is wide open endpoint, no authentication whatsoever. And not only could I put my email address, I could put any of yours as well. And if you were not a Duolingo account, it would probably return an error. But if you were, it would return this, right? And kind of the remarkable thing was, for a long time, Duolingo didn't consider this an issue, right? They're like, this, what's the big deal, right? It's not any PII in here, right? You don't see, like, my home address or anything like that. But this is gold for like a phishing campaign, right? Like, imagine, I'm about to hit my 1,000th day and I get a message like, hey, special gift for you, right? You can do all that right from this one page. Okay, so the other thing that's kind of remarkable about it is, in order to get that 2.6 million, they probably had to guess 200 million times, right, to find 2.6 that actually matched. So an extraordinary volume of attempts to achieve that kind of extraction or exfiltration. So this is a great example of API number 2, which is also unchanged, and number 2 for a very good reason, which is broken authentication. More often than not, it's not weak or poor authentication; it's no authentication, right? And so this is what we see, like, API endpoints that people don't expect to be discovered, that do, and those API endpoints are over permissioned and don't have any credentials, or don't have any authentication controls. Charles, why is this a leak? Well, I guess that's debatable whether you consider it a leak or not. 2.6 million records belonging to your organization probably is not something that you want out there. This is valuable information, right? It's for sale on the dark web. There's certainly a very significant reputational impact. So, as security teams, our job is to, continue to protect the organization's interests. So I would very much consider this a significant leak. I think initially Duolingo did not. They have fixed it partially. And so now if you were to try it out, it wouldn't return all this data, but it would still distinguish between a user and a non-user. All right, let's move ahead. Next one is Venmo. And so here someone found an API endpoint that powered a feature on the homepage that would show you the most recent transactions, right? Like, Dan paid Christine $15, whatever it is. But the UI would strip out all the personally identifiable information, like last names, account details, all that kind of stuff. Well, this person found an API that was powering that functionality, that feature. That API was accessible with no authorization, as you can see here. But beyond that, it would return all the records, all the fields of every transaction that they requested. And you can see here on the right, 207 million transactions got harvested here through this API endpoint, right? And so one of the pro tips here is, even though you think your APIs are hidden, no one's going to find them, right? They're behind the scenes. They are very much discoverable, right? And attackers are specifically looking for them, right? So this is an example of a new one, broken object property level authorization. And this is actually a merger of two items from the 2019 top 10, which is mass assignment, the ability to modify and change object values and records, and excessive data exposure. And this is a great example of excessive data exposure, right? It was no longer filtering the data. It was revealing all the fields, all the details of every transaction, right? And so you want to make sure your API is tailored to the use case, right? In this case, the use case was return anonymized data that the UI can present. Instead, the API returned all the data and relied on the UI to do that filtering. Okay, I'm Merrick and Siddharth. This is an hour-long webinar, and it is recorded. So if you can't join us for the rest, we'll certainly make sure the recording is available. This was also a good example of API number 4, which is unrestricted resource consumption, which used to be called lack of resources and rate limiting. And basically, this is volumetric attacks, right? When you see 207 million records harvested from Venmo, or 2.6 million from Duolingo, and many other examples, 4 million from Peloton, that's a volumetric attack, right? And you really want to make sure you're employing this, detection and traffic shaping, and prevent these types of high volume attacks from happening. Okay, so that's number 4. So let's talk about API number 5. And the example here is Bumble, which is the dating app. So they had an API that, first of all, required no authentication to access, had access to all 100 million users. You could even do things like triangulate, create 3 accounts, and then find the exact location of any user on the platform. But the reason why this is an OWASP number 5 example is they exposed an endpoint that really had no reason to be shared publicly, which is the endpoint to modify your account type. So if you were a free Bumble user and you wanted to have the benefits of paid, you could go find this API endpoint and literally change your account from free to paid, or for anybody else's account as well. And so that is an example of number 5, broken function level authorization, right? So this is an abuse of functionality or capabilities of your application. In this case, an endpoint of set user account type really should only get invoked by a backend process after I've made my payment and so forth. But as I turned out, it was exposed publicly. It was accessible without credentials, and you could literally override whatever was written there and say, okay, these users are now paid. Okay. So that's number 6, or that's number 5. Number 6 here, the example is Instagram. And what we're talking about here is an abuse of business flows, right? So with Instagram, if I wanted to take over Taylor Swift's account, here's how I would do it. I'd go pretend to be her. I would say I forgot my password, and they'd issue a 6-digit code. All right, that's a million combinations. And turns out that I can supply my guesses through an API call. So great, I'm just going to start at 1 and make my way all the way up through 1,000,000. But once I hit 200, it would stop. Right. This researcher found out that, like they could get from 1 to 200 and then no longer submit anymore. So what they tried was to just change their IP address, and it let them have another 200 guesses, and then change their IP address again, and they got another 200 guesses. There was a 10-minute timeout, but with APIs, it's pretty easy to basically script that and run through all million combinations and literally take over any user's account. And that's a good example of a new one on the top 10, which is unrestricted access to sensitive business flow, right? So here, the sensitive business flow is the account reset process. And really, they should have disabled that account or that reset code completely after a handful of guesses. But it turns out that if you just change your IP address every 200, you could keep guessing. And that's what this one's all about. Moving on to number 7, this is a new one. I don't have an example of it, but it's a really important one, which is server-side request forgery. So really the main point here is, like, whatever's coming into your API, do not trust it, right? Like, unless it looks like what you're expecting for that API endpoint, you can't trust it, right? So if you have like a user profile functionality where users provide their name, address, email, a LinkedIn profile, Twitter handle, whatever it might be. Let's say in that LinkedIn field, right? Instead of putting, www LinkedIn, my profile, they inserted /localhost user data, or Etsy password, or an injection, or a link to a malicious, malware site, right? You've got to validate what's coming into your APIs and make sure it matches what you're expecting, right? And that's what server-side request forgery is really all about. Okay, so let's keep going here. I'm just checking the chat. All right, these are great questions. I will get to them. All right, number 8 is I don't have an example for this either. It's carryover from 2019, but it's kind of a catch-all for misconfiguration type of vulnerabilities, right? Patching and setting cores policies, and doing your hardening, managing your permissions, setting encryption, and the like, right? And we have a great course called Securing API Servers, taught by my colleague Anthony, and highly recommend. It's a great course to really understand kind of the blocking and tackling of keeping your API servers secure. And number 9, we've got a good example here, which is Experian. So this is the credit reporting agency, one of 3 here in the US. And they developed an API that was designed for their trusted partners, right? So if you're a bank and you had a loan applicant and you needed to check someone's credit score, that's what this API was for. And you could actually, use it in your application process and the like. And so what happened is one of these trusted partners thought, oh, this is a really nice thing. Why don't we, add a feature to our website that allows any user to come and check their credit score? And in order to do that, they would need to supply their name, their address, and their birthday, right? Well, somebody found this feature and tried it out and thought, well, that's kind of handy, and discovered the API that was powering it, and that API was coming straight from Experian. So they called that directly, and it worked. And they tried to look up their own records, and then they tried to look up their partner's records, right? They knew the name, address, birthday, and it worked for them too. And then I think they probably tried their neighbors, right? And they knew their name, they knew their address, and they just guessed at the birthday, and it worked. And it turns out you could put any value in the birthday field and it would work, right? And so 60 million credit scores got exposed through this vulnerability. And this is an example of a new one called improper inventory management, right? And really what we're talking about is, how do you control who's using your APIs and what they're doing with it, as well as how do we control, what APIs we're even making available, right? And so a lot of times what we'll see is versioning issues here with API. So let's say you upgrade your API from version 2 to version 3. And typically what happens is you'll change your path from /API/v2 to /API/v3. And any good attacker is going to see that and then go back and say, all right, is v2 still available? Is v1 still available, or other common paths available? And they might find that you've got those old versions still hosted, still accessible with outdated logic or outdated endpoints. And that can cause you issues, right? So that's what number 9 is all about. Number 10, I don't have an example for. It's also a new one, which is unsafe consumption of APIs. And here we're talking about the APIs that you use, right, from third parties. So say you're using like DocuSign API, right? Again, you need to treat those APIs like your own, validate everything that's coming back from them. Don't trust the data unless it looks like what you're expecting. And really, pressure test those APIs as you would your own to make sure they're not introducing any vulnerabilities. Okay, we have a couple more here that I just wanted to touch on. Connected car is a really big deal for API hacking. Really remarkable man, Sam Curry and his buddies did incredible research. You can find the link there. Just go to samcurry.net and successfully hacked almost every car that they tried to through their mobile apps and web apps and the like. We're able to do things like lock and unlock doors using nothing but a VIN, which is right there on the windshield, or an owner's email address, start and stop engines, locate and flash lights and so forth. So really remarkable things that they were able to accomplish through vehicle APIs. Even this last one's kind of remarkable for fleets. They could literally disable ambulance starters, right? So think about the harm that could be done through these API vulnerabilities. And then the last 2 are, I'll just touch on quick hacktivism examples. So here, the group Anonymous used an API to send dozens of taxis to the same location in downtown central Moscow, right in front of the Hotel Ukraine, and just jammed up the city for hours, right? And more recently, a pro-Hamas group found a flaw in the Red Alert app. This is an app that notifies Israelis of incoming missile attacks and things like that, and just flooded it with fake alerts and horrible messages, and really rendered this important app totally useless, right, through an API exposure. Okay, so what stands out? All 10 of these OWASP entries are super critical. But when I look at the breaches, there are 3 that really stand out for me, right? Number one, broken object level, right? User, a hacker being able to access, dozens, hundreds, millions of other users' records. That's an authorization flaw, right? And we see lots of examples. We see lots of examples of broken auth, and more accurately, no auth, right? APIs that shouldn't be public that are, all right, and aren't behind any kind of controls or credentials. And number four, right? Anytime you hear me talk about millions, that's a resource consumption flaw, right? Like, we have to do better to make sure we're detecting these types of volumetric attacks and preventing them from causing huge leaks of information. Okay, so now let's pivot into what can organizations do to keep their APIs more secure. And we kind of came up with this framework a couple of years ago, and it really has worked. It really has stuck, which is, we call it the 3 pillars of API security. It's a great way to just think about and frame your security programs for API. And we really believe it starts with governance, which is how do you go about developing and creating and testing and hosting and operating your APIs. Then there's testing, right? Which is, of course, how do we make sure these APIs are secure and free of vulnerabilities? How do we do that against every release, ahead of production and the like? And then monitoring, right? How do we detect those volumetric attacks and make sure that our controls are working and so forth? So I'm just going to touch each one of these very, very briefly. And Abdullah, I see your comment about AI and LM. We actually have a whole course on that. We did a webinar back in December on that very topic. So stay tuned for more there. But on the governance side, we actually have a whole course coming on this as well. So I'm just going to touch on it very, very high level. But really, we think about two aspects of governance, right? So one is just the awareness, right? Have an inventory, know what APIs you've got, know what they're doing, what data do they have access to, what kind of policies are we enforcing on that, what authentication is required to access the data that API has access to, right? And do the risk assessment and so forth. So that's really kind of a know your ecosystem. But then there's the policy process, right? And we really believe you should invest the time, get the different groups together, security, dev, ops, risk, compliance, you name it, and map out your organization's policies and processes for developing APIs, right? Set your style guides. Like, how are we going to develop these in a consistent, common way? What are our documentation requirements? What are authentication? Do we host everything in a central gateway? All of this stuff you should really sit down and think hard about and map it out and make it the standard for the organization. On testing side, I've talked about this a little bit up front. This is that report from Rapid API. We're doing a whole lot of functional testing, integration testing, performance testing, and the like, which is really about, does this app do what it's supposed to do, right? Like, can that user on Coinbase trade on assets that they own? Yes, good. But way down the list at 4% is security testing, which is, frankly, does the app not do what it shouldn't do? Or in the case of Coinbase, can a user sell something they don't own? They didn't run that test. If they had, they would have quickly found it and saved themselves $250,000 in bug bounty. And that's really what we, the kinds of things that we need to be thinking about from a testing perspective. And so here, my pro tip is, let's involve development and the people creating and defining APIs into this security conversation and make sure they are aware of what those risks are. How are APIs getting attacked? Because if we can provide that kind of insight to the developers, they're going to create more resilient, more secure APIs right off the bat, right? So enrolling them in courses like this, doing workshops for the organization is very, very helpful in achieving this. And just, when we think about testing, it really covers a lot of ground, right? There's security aspects of testing, like looking for unsecured endpoints or incremental IDs that can make it easy to harvest, running injections and fuzzing and all these kinds of scenarios. Then there's data-oriented tests, right? So like access controls, authorization controls, right? Are we revealing too much data? Is there sensitive data? Is it mapped well to what the business requirement is for that application or for that API? And then on the far right, we've got logic, right? So you take that Coinbase example, that's a logic flaw, right? And so are we testing, are we looking at the ability to manipulate object IDs? Can user A access user B's records? You know, are there RBAC permissioning issues? Are things changing that we don't know about that we need to detect? So this is just a kind of a sampling of the things that you should be thinking about from a testing perspective. And then finally, from the monitoring side, right? We really think there's three elements here. So there's runtime protection. This is typically done through an API gateway or like a web app firewall, right? Super critical. The gateway can do things like enforce policies. It can do rate limiting. It can authenticate your users, your WAF. Can do traffic filtering and things like that, right? So these are really, you know, active blocking and tackling for your API runtime traffic. Then in the middle, you got threat detection, right? So can we detect signs of fraudulent traffic and alert on it or even block on it, right? Can we see volumetric attacks as they're happening after 10 or 20 or 100 records, not after a million or 100 million? Right? Can we do the incident response by looking at the logs that you know that come off the WAF or the gateway to understand like what happened here and how do we prevent that from happening again in the future? And then lastly, how do we make sure that the stuff that we're implementing is actually working as designed, right? And we've run into many situations where we'll run a set of volumetric attacks and they'll work. And the security team will scratch their head and say, well, how's this happening? You know, we have a WAF in place. It should be blocking it. Only to learn that somebody, you know, changed the config and it went into monitor mode instead of blocking mode. And that control was not working as they intended. Right. So another point here for monitoring. The pro tip here is, look, monitoring is important. It's also reactive, right? So it's going to tell you things after the fact or as they're happening. And those like logic style attacks, those authorization attacks like Coinbase, are very likely not going to get discovered in runtime, right? It looks like real traffic. There's not enough context to know, and is Dan accessing his records or is he accessing Christine's records, right? There's really no way to make that kind of judgment in runtime. So make sure you complement this with really rigorous testing. All right, so that brings me to our last sort of meaty slide of the presentation, which is kind of like, you know, the top 10 best practices that we've kind of observed from, you know, spending a lot of time with organizations like yours over the last couple of years. So number one is to start with governance, right? So we're really big believers, like, you know, it's very appealing to security teams, like jump in and start plugging holes and implementing this tool and that, which sometimes is necessary. But if you want long-term, you know, solid API programs, start with governance, bring the teams together, talk it out, come up with your approaches, your policies. Related to that is to know your API ecosystem. So have an inventory, know where your APIs are, what APIs are out there, what are they doing, who's accessing, who owns them, how are they being run, all of that kind of thing you should know. And one of the best ways to get there, or really to achieve all of these in the top 10, is to increase the collaboration and the communication happening between security and development. We run a lot of security teams. I'll say, oh, we don't have a clue what APIs we got, right? Or we don't know what a Swagger file is. And you know, if you were to walk over to the security or to the dev team, I guarantee you they have a pretty good idea, right? They know what they're building, they know what they've got. And so, you know, it's a really important collaboration that needs to be nurtured and cultivated. I've heard about CISOs that actually take members of the security team and drop them into different dev teams and just, you know, literally sit together, have lunch together, you know, have conversations. So it's really critical to achieving this kind of security collaboration that we really need. Number 4 here on the list is API documentation is not negotiable. And whenever I hear about APIs that are not documented, that really can't happen, shouldn't happen. If it's happening in your organization, you've got a governance problem. It should be mandatory, not just because API documentation makes your APIs usable, right? If someone else is going to use my API, they need to have that information. It's also really valuable from a security perspective, right? Now your security team can look at that. They can generate tests. They can generate WAF rules. They can do lots of things with that documentation. If they don't have it, you're making their job way, way harder, right? So not negotiable. Have your documentation for every API. Let's train our API developers and owners. We've talked a lot about this, right? Make them aware of these types of things. They'll build more secure, more resilient APIs as a result. Whenever I hear about like shadow and rogue or unknown APIs, that's a governance problem, right? You got a governance problem if that's happening, right? There was an example in Australia at their big telco. I think a QA engineer created an API. It somehow got published onto the internet. It was public facing, had access to all 10 million users, right? That should not happen. There shouldn't be some random way for APIs to get live. If that's happening, you got a governance problem, right? And one of the best ways to prevent that, centralize your API management. Use a gateway or something like that and make sure everything goes in there, right? If it's not in there, it doesn't go live, right? Number 7 is input validation. So don't trust anything that's coming into your API endpoint. It's just don't. If it doesn't look like a LinkedIn address, then throw it away. Maybe block that IP address or something like that. But do not trust what's coming in. Make sure you're doing proper input validation. Don't rely on the UIs. Geez, like almost every one of these breaches I talked about, they saw the UI, they watched the traffic, they went straight to the API. Right? They just bypass your UI altogether. Your UI is for presentation. It's not for enforcement. It's too bad. It's a real nice, convenient place to do it. It's not effective. Not in a world of APIs. Authentication is not authorization. I think we beat that one to death, right? Just because you're authenticating an API doesn't mean you're done, right? You got to make sure that users can only do what you authorize them to do. And most of the time, that logic exists in the application itself. Right. And then lastly, this one's close, near and dear to my heart, automate pre-production testing. Right. So you saw that big long list of different things that you want to test. If you're doing a pen test once or twice a year, but releasing code 52 times a year or 365 times a year, that's a lot of code going out without testing. Right. So what that means is automation is super critical. Right. We got to automate our testing. We got to shift it left, right? Test ahead of production. And employ AI and things like that to really kind of give us that coverage of our applications. And if you want to learn more about that, please come talk to me. We know a lot about that. So that's our talk here. I'm gonna put this back up here. So again, if you want to get you want to win one of our CASA exams, CASA is the certified API security analyst exam. And it's normally $125 on our website. We're going to give away, I think, like 10 of these CASA exams. And the way you can enter is to take our market survey. So we're doing this survey to learn more about your challenges, what your organization, what you're seeing out there in the real world. So please take like maybe 5 minutes to fill that out, and you'll be entered into take one of our CASA exams. Andreas, the course you want to take to prepare for CASA is our OWASP course. So you see right there in the middle on the right, OWASP API Security Top 10. It's a course from Corey Ball. Fantastic course. That's your prep for the CASA exam. Right. So make sure you've taken that course ahead of time. Now, there's a couple other things that I want to share with you. We've got a webinar coming up in 2 weeks. And let me pull that up here. Right. So this is going to be a lot of fun. We're actually speaking with a really great expert on API gateways. Right. So gateways are a really critical part of the stack. Right. It's really what, where all your API traffic, terminates and moves into the organization, or at least for folks that employ gateways, which we highly recommend. And we're actually going to be launching a course on API gateway security best practices in conjunction with this webinar, right? So we'll have that new course on the 24th, as well as a webinar on it with a really great expert and the instructor of the course itself. So please please consider joining that. And I'll stall a little bit because I have one more thing to share here as well. And I don't think I can put them both on the screen. Yeah, all right. Maybe, Christine, you can put that webinar. Oh, access to the webinar is disabled. Huh. Maybe, Christine, you can figure out what's going on with that. We'll make sure to send the webinar. I might have put the wrong link in there, but we'll send the access to the webinar here in the follow-up email, and maybe, Christine, you can dig that link up and put it into the chat. But the other thing to mention here is rate limiting. Oh, interesting. Well, thanks for so much interest in the webinar. If you like this session, this API security workshop, and you think your organization would benefit from having a conversation like this to raise your organization's awareness, we do this all the time. There's no charge. This is something we just do out of the goodness of our hearts, I suppose. But if you want to have a session, and you can bring your dev team, your security team, your compliance teams into, please fill out that form. We do our best to say yes to everyone. We can't always do it, but we'll certainly do our best. And we'd love to help you with your efforts to raise awareness into API security. So that's that. And I guess my last slide is just to say thank you. As always, really appreciate you all being here. I do want to hop into the questions here, so I'll leave that slide up for now. And I'm gonna replace that. I'm gonna bring back our market survey because I really want to leave that one up there, and really encourage folks to hop in and share that. So thank you everyone for the nice comments, and always be in touch. There's my email. Look me up on LinkedIn. All right, so I'm going to hop back into the questions here. All right, do you have a platform for API security testing that is scalable, 30,000 endpoints or more? Lexter. Geez, what a wonderful question. I mean, that's, we don't talk about it a lot because we keep this site vendor neutral, but come hit me up. We have a technology for a company I work for, APIsec AI, that does exactly that. It's an API security testing automation platform. I'll leave it there. But definitely, if anyone's interested in that, send me an email and we can talk. Okay, how do I identify automatically when API development release a new endpoint? Great question. So another reason why you want to centralize your APIs in a gateway. One of the things that we do a lot is query the gateway, right? Whenever we're going to do an assessment or something like that, and pull the latest definitions. If a new endpoint gets added, we're going to know about it, right? And that just goes back to automation, right? Have that process where APIs go live into a central management layer, and then integrate there to be able to make sure you've got the latest and greatest information. So that's what I would recommend, and hopefully that'll work for you. We talked about the Duolingo leak. All right, how a security team can be legitimate to enhance security level of API when vulnerabilities are logical. Fixing this would mean to implement TDD, BDD in the DevSecOps approach. All right, I'm not sure what those acronyms mean, but I get your point, right? So how can security teams help when the fix is a logical fix? Well, number one, you can be actively testing and finding those vulnerabilities, right? Whether it's through your own red teams, a pen test, some sort of automated testing tool. Find the flaws, right? Now that you've discovered that there's a logic flaw, you got to go back to dev, right? That's where the fix is going to be implemented. And wouldn't that be a whole lot easier if you've already got the relationship? You already know who to talk to. You've got that rapport in place, right? That's why I really believe strongly that we need to cultivate this collaboration between the security and dev teams. Let me see what we got here. In the context of number 4, if someone is patient enough, won't they be able to eventually leak large amount of information over a very long period of time while staying under the radar? Yes, they could. Yes, they could, right? It's called a low and slow attack. It's a very common thing. I think in the case of Venmo, that's what the guy did, right? He was getting rate limited, so he just dropped the rate down. So, you might need to get more sophisticated, but yeah, attackers are going to make their traffic look undetectable or look like normal, but you still have a problem there, which is authorization. Like, I shouldn't be able to access your records or a million others, even if it's low and slow, right? So make sure you're employing the right authorization controls to prevent users from being able to harvest in the first place. Or stop doing things like having user IDs that go from 1 to 2 to a million, right? Like you're making it easy for folks to harvest. Have a digit in there or a letter or a symbol or something that makes it impossible to increment through your database. All right. How do you start advocating for API security in a big corporation? I work as a consultant in a bank, in an IT risk team. Dev teams lack a care for security in their process. Well, number one, like maybe we can get them to try to schedule one of these API security workshops, right? We've done this dozens of times. Maybe get some senior leadership on board with it. Say like, this is important. We're gonna make it. We're gonna schedule this thing. We're gonna record it. We're gonna invite everyone who needs to be part of it. That's one way to do it. Another way to do it is to um, bring our courses in house. So one of the things we also offer is the ability to install APIsec U courses in your own learning platform. This is very popular because a lot of organizations, when they want to make, like, for example, this fundamentals course mandatory for all developers, right? Well, it's hard to do when you have to send them to our website. You can actually take our courses, bring them into your own learning platform, and then assign it to people. Again, get security and dev building that collaboration. So like, let's find ways to blend security and dev together. So hopefully that gives you a few ideas on what to do to build a culture of security. Shaquille, how do we mitigate SSRF on an API level? This is really about input validation, right? So again, that's probably going to be at the logic level, right? But we need to make sure that whatever's coming in is validated and nothing happens with it until it meets a certain health check, right? And that's really the best practice for preventing SSRF type of vulnerabilities. Jessica, is there any workshop after these, like episode 2? Yeah, this is the first one that we've done like this, and Christine and me and the team were thinking like we want to do this every month, right? So hopefully this was a good use of your hour. I know we're right at the hour here, but yeah, we'd love to do more of these sessions, and we do run webinars regularly, like the one in 2 weeks on API Gateway. So please make sure to register for that. And then the last question here from Andreas, which API security test or course for the CAS exam? Yes, you want to take the OWASP course. So thank you all for that. Right on time here. It's the end of the hour. We are recording this. We're going to post it online. We're going to share the recording with you. Thank you so much for joining me here this Monday morning, and look forward to seeing you again soon, and have a great day, everybody.